We're going to talk about a little extension of the graphing of sine and cosines. So we're going to graph compounds, which means we're going to graph either the sum or product of two trigonometric functions or a trigonometric and a linear function. Let's start with the trigonometrics. So what I'm going to do first is I'm going to add the sine and the cosine graph, and I will take and graph each independently first. So let's start at 0, and we'll just do one period of this. Goes 0, pi over 2, pi, 3 pi over 2, and 2 pi again, which we've been doing for quite a while now. My sine graph goes between 1 and -1, and we go from 1 to 0 to -1 to 0 again, and we know that looks something similar to this. The cosine graph starts at 1, goes to 0, down to -1, up to 0, and back to 1. So that graph's going to look very similar to this. So now what I'm asked to do is I'm asked to add all the values of sine to all the values of cosine at each individual spot. So I'm going to pick some I guess, critical points where we can see some easy additions. Here's an easy addition. I have a value of 0 and a value of 1. And 0 plus 1 is 1. Here I have something close to 1 added to something close to 1, which is something more than 1. So I'm going to put that value up here. All right. Next, I have a value of 0 added to a value of 1, which is value of 1. Now you'll notice here I've got this ruler, and I'm going to take, I don't know what to do right here. So if I look, I'm roughly, about 1.5 inches above that axis. So to the point directly below it, I'm going to add almost 1.5 inches. And you don't have to have this ruler, but what you can do is you can just, gauge it by the size of your finger or what have you, and add those values. So if I add roughly 1.5 inches, I'm somewhere right here-ish. All right. And now let's use another nice and easy point to graph. I've got this point, let's see. Switch colors of pen, sorry. I've got another point of 0 here and a point of -1. That's -1. Put a little X here. Here's another situation. I'll just use the ruler for kicks. This point is roughly almost 1.5 inches again down. But notice I have two negatives, so I'm going to go 1.5 inches down from there. So roughly here. And I will graph that point somewhere roughly here. Right? And again, this is a rough estimate. It's not exact. Okay, I could find the exact values, but why? And then I go back and I continue to just add my zeros and ones again all over the place wherever I can, somewhere right around here, and I end up over here. So connecting the blue dots goes up very high, drops down low. Once again, it's just a sketch. Go down a little lower, and then you come back up. And the blue graph is the graph of my compound. Let's do another one. So now we're going to graph two trigonometric functions with different periods. So I've got to be a little more careful in this case. What I'm going to do is first find the period of this function. I know the period of sine of pi over 2 is equal to 2 pi over the k value, which is 1/2. So the period is actually 4 pi. And if I look at my intervals, all right, my intervals are going to be in terms of 4 pi divided by 4, or pi. So really in 2 pi, if I go from 0 to 2 pi, only half of this second graph will be represented there. So if I'm graphing a sine function, and let's do this guy in blue, and we'll do this guy in green, or whatever color that is, red. All right. So the blue graph, remember, I'm going to go from 0 to 1. Let's call this 1 and negative 1, and back to 0. So that's my blue graph. If I wanted to do the whole sine graph, it would take me 4 pi to get that done. I go over to the red graph, and this is 2 cosine. So my amplitude is 2 in this case, and negative 2 in this case. So I start up at 2. My intervals here are pi over 2. So I'm going to go to 0, go down to negative 2, back to 3 pi over 2, and back up to 2. So if I graph the green one, here's the graph of 2 cosine. Once again, rough sketch. And then if I connect the dots on the blue, I really have half a sine graph. So now I have to add the green and the blue graph to each other. So if I'm going to do that, again, I like adding zeros and ones a lot. So let's do it in yellow this time. So if I add 2 to 0, I get 2. Now I'm going to add a number close to 1, but not quite, to a number close to 1, and I get something in between there. So I'm going to add this. I have a value of negative 2 added to a value of 1, which is negative 1. Here, I'm going to use my ruler again just for kicks. And I'm going to say, all right, well, the blue graph is up roughly an inch. So if I slide that directly down to the green graph and go up an inch from there, that's going to put me right about here. All right. Slide that back over. So this little yellow dot is going to signify the addition of the two values. Now I have a 0 again and this blue line, which puts me right here. Here's a number almost at 1, added to another number almost at 1, so it's a little bit above. And then here's another 0 adding the 2. So when I graph this, connect the dots on the yellow, come here, going to drop down again to this new yellow, go back up, and roughly here. So that's going to be the sum of the two. Excuse. Next slide. Okay, so now two things are a little bit different here. We now have the graph of y equals x. This is linear. Spell it right. And cosine x, which is trig. The other difference is we have a subtraction. And if I have I hate dealing with subtraction, so what I'm going to do is I'm going to change this to x plus negative cosine. Not much of a change, but you'll see how I look at it. It's kind of a personal preference type of thing. So we're going to graph anything that has a linear and a trig function. We're always going to put in terms of pi's. Because if I'm in terms of pi's, this is 6.28. And it just scales better if we take and graph in terms of radians when we have a linear and a trigonometric. And I know pi is 3.14, et cetera, 1.52, I think, ish, so on and so forth. So if this is my value of 1, then an equal amount away is 1.5. So if I have to graph y equals x, I now have a relatively equally scaled setup. These are both negative, of course. So if I want to graph y equals x, then I go over 1 and up 1 from 0. Puts me roughly here. this is linear. So I have a straight line going up. And in theory, this line would also go down in the other direction. We don't talk about that much, but you can always go backwards. And I'm going to do that just on one of them. Now, next we're going to graph y equals negative cosine of x, which means my amplitude, my y values are going to multiply by a negative. So instead of starting up at 1, I'm going to start down at negative 1. Then go to 0, positive 1, 0, and negative 1. And now I'm going to graph the addition of all the numbers on the curved line to the numbers on the black line. And we'll do this in blue. So I have a 0 plus a negative 1, which is a negative 1. Now notice, here's another 0. And it's going to add to the black line. So here I am. This is a 1 added to the black line. So you can see that value is way up here. 0 added to the black line, that would again be somewhere way up here. And negative 1 added to the black line would be somewhere over here, which I can't see on this. Now, once again, let's look at some of the middle values. If I take and use my ruler, I notice my ruler goes down almost 2 inches from the horizontal midline to this curved cosine function. So I'm going to move my ruler up about that amount, and I'm going to say, okay, well, now I'm going to take and write in the value of almost 2 inches dropped from that vertical line. Once again, I'm going to look at another intermediate value and say, all right, whoops, sorry about that. I'm going to take a look at that line once again, and God dang it. There we go. And I'm going to figure out how high the curved line is, which is about 1.5 inches off of that midline. So relative to this black line, I'm going to go up 1.5 inches and put a blue X. And it's roughly here-ish. All right. Get this pulled out of the way. Whoops. Having problems, as you can see. And then I'm going to take and connect all those dots. So let's do that in blue. Connect the dot. Connect the dot. And I ran out of some room, but connect the dot again. All right. So this graph is going to look something like this. Now, again, if I were to continue the black lines going back in the other direction, all right, I'd be adding those two together, getting a number a little less than -1 added to a number less than -1, somewhere around here. This is 0 plus the line. Again, gets me back here, and this graph ends up wrapping this way. So it's really no different. You're just adding a linear line to a trigonometric curve and adding the values on each. Next, we're going to go to a multiplication, which again is just a little bit different, because we're going to be multiplying the two values rather than adding the two values. And in this case, we're going to graph cosine, which goes from +1 to -1. We're going to put our 1.5s in there again. So that we can match up appropriately. It's a little bit more. Put our pi/2 here. Pi, 3 pi/2, and 2 pi once again. Again, if I do my linear graph, I go over 1 and up 1. Here's my slope of that line. And we might run out of room again. Looks like we did. can go back in this direction. And we're going to graph cosine, which goes 1, 0, -1, 0, 1. Draw the line. Have this curve. We're going to multiply these values together. Remember, we're multiplying. So I'm multiplying 0 for the linear function and 1, which is 0. Multiply a number a little less than 1 to a number a little less than 1. That's multiplying two fractions less than 1, and I get something even less than that. Multiply 0 to 1.5, and I get 0. Multiply -1 to whatever this value is, and I get the negative of this value. So I look at this distance. We're going to take our lovely ruler once again and say, all right, well, how high is that linear line to this curvilinear? It's roughly 5 units up. So from this origin, or this horizontal line, I'm going to go 5 units down, which puts me roughly here. Now, once again, I'm going to have a multiplication of 0 in here. I have 0 times whatever value this is up here is still 0. So notice what's happening to this line. I go up, down, way down, back to 0, and I'm going to be multiplying here 1 times whatever value is way up here. So it's going to be somewhere way up here. So it goes way up. Now let's go back. If I was to take and continue this graph in the opposite direction and get -π/2 here, this graph would go down like so. I multiply 0 times anything, and once again I get 0. So what's going to actually happen over here is this is a negative value times a positive value, and a negative value times a positive is a negative, so I'll get some graph over here, get back to 0, and -1 times whatever value this is going to be a negative times a negative, which is a positive. So I'm going to grow up over here. So this is actually going to mirror the other side. So hopefully you understand the moral of the story is draw the two graphs, do a rough approximation of each of their values, and then add or subtract those two values together to generate a new graph. And with that, here are the questions we need to answer today. So we've got a multiple choice for your first guy. And on the second one, you're going to take, as soon as the second one comes up, and you're going to do another multiple choice and figure out which graph is the sum of these two. Take a look at the intercepts and what have you and see which one is added together. All right? See you tomorrow.